going into the field of data science is challenging, especially if you are a small enterprise with not much funding and resources. Note that it can be very expensive, not just expensive in terms of buying equipment or setting up your own system. It can be expensive if you aim to build your own data science team, because data scientists are expensive. No? So the manpower aspect is also challenging. And then we also notice the lack of data strategy. This is more for the large enterprises. Data strategy, I think it needs an entire session to discuss that. But basically what it's saying is that the technology needs to be linked back to the strategic imperatives of the organization, right? This is not just about having a data science team. This is having a data science team that helps you truly achieve what your goals are in the short term, in the medium term, and the long term. And finally, what we notice, and this is exciting for students in the field of STEM, the demand for talent is skyrocketing, right? But there's not much talent around. Again, this is not just true in the country, but in the region and also globally. And when we say lack of data science talent, it's not just the lack of, like what Pros said earlier, it's not just about the hard science skills, no? Because you are now integrating it with the business. So you also need to have the skill to communicate, just like what Candy said, because you're bringing in change in the organization. I'm going to give you an actual experience that we had. These are examples of multinational companies. We have worked with some of the companies here abroad as data scientists at AIM. And one of the most striking thing that I can never forget was a chief information officer in one of the most innovative countries globally, approached us in one of the talks that we gave. And the person asked us this question. He was saying that we have a lead data scientist in the company, really brilliant machine learning scientist, and is being paid big money, but he's not bringing value to the company. This is not even paraphrased. And we were at the corner, and then the CIO asked, what are we doing wrong, right? And again, it goes back to the idea on communicating with the industry. We always talk about the triple helix, but it seems to be a very difficult goal to achieve, or very challenging. And one of the main reasons that I see there is really communication. So those of you, high school students, right, going into college, go into STEM, but also don't forget the soft skills. They're very important, because now scientists and engineers are not just boxed in the academy, but now we are really working closely with the business. What does this mean? Science graduates and scientists need to learn how to speak the language of the enterprise. Okay, it's not just about the data of the company. Okay, of course, that's exciting. But it's also not just about the models that we are building. That's also very exciting, the algorithmic innovations. But if you want impact outside of the field, you have to understand that insight is the new currency. Okay? Anong ibig sabihin nito for our high school students? When you say insight is the new currency, when you show results, when you show numbers to the stakeholders, to your partners, to the industry, you should be able to answer the question, so what? No? So what kung yan ang result mo? What does this mean for us? What can we do with this insight? It's not easy to do, but with practice and with exposure to individuals outside of your field, you get to understand how to communicate better. So this is where we're coming from when we designed the data science program at AIM. And later I'm going to talk to you about the joint collaboration. What are the things that are required, right? Because at the center of the field of data science and AI is really data. However, it has to work with various domains and sectors like the industry, the society, the academic institution. So our idea when we designed the program is that we want to help industry. So that is very clear. We want to help industry innovate even while our students are finishing their degrees, not after. We want to help them remain competitive because right now, companies are competing in the field of analytics. So we want to provide service and manpower because, again, there's a lack of data scientists in the country and in the region. We also want to help society to remain relevant and significant for them and to work closely with government to somehow improve their services. And I'm going to show you concrete examples on how we do this. And of course, we're still an academic institution. So we have to also focus on that particular aspect, contribute to the growing and pool of knowledge of analytics and computing, properly training our graduate students in both theory and also applied science. So again, I am from the Ancient Institute of Management, the Ambiguity School of Innovation, Technology, and Entrepreneurship, which is just one of the 4 schools under AIM. And within this school at AIM, we have 4 different degree programs. The Master in Entrepreneurship, this is enrolled by businessmen who own their own businesses, who have their own businesses. And then we have the Master of Science in Innovation and Business, wherein you have these students who aim to have their own startup companies. You know, they're interested in the innovation journey. They want to be part of the innovation department of enterprises for corporate innovation. So that's the program for them. And then we have the MS in Data Science and a PhD in Data Science under a site. But what's interesting here that's very unique about AIM and about how we do this research with the industry is we have a lab that we call the Analytics, Computing, and Complex Systems Laboratory. Okay. What's unique about A-Site compared to the other research groups in the academic institutions here in the Philippines is that Access Lab, houses full-time research scientists and research engineers. They do not have to teach. They do not have to mark and check papers. So they can truly concentrate on doing research, okay? And another important ingredient here, as you will see also later, I'm gonna emphasize in this position, is that we have an industry development manager who's also a scientist. The goal of that person is to communicate to the enterprises, understand their business problem as an analytics problem and communicate it back to Access Lab with the scientists. We also have a program manager. Of course, it's very important that you have a very skillful manager for all the projects that we need to take in. I'm going to give you some numbers later. But aside from these manpower resources, we also house the fastest AI supercomputer in the Philippines. In fact, Super Georgie, that's what we call the supercomputer, was recently featured in Asian Scientist Supercomputing Asia, together with national computing centers in Singapore, in Thailand, in Indonesia, and Malaysia. So all the other 4 are national computing centers. And then from the Philippines, we have a business school representing our supercomputer. So that's something that we're truly proud of. But another thing I think that would be interesting for educators here is the role of Access Lab. The role is, again, I mentioned earlier, to engage private and public organizations in research and development. It is part of AIM's consulting arm. Okay, so that's really the meat, the core of Access Lab. But then at the same time, its role is also to engage our MS in data science students, right? It's like for the high school students here, it's like doing an internship, right? But this time you just stay in school, but then you're being trained by real data scientists who are engaging in projects with the industry. Okay, now I'm at a point where I will share with you the kinds of engagements, the 2 types of engagement at AIM Access Lab. So there are three entities that I want you to familiarize yourselves with. The first one are our collaborators. This is the government, industry, international organizations, and nonprofit organizations. So these are the people who would like to work in AI R&D projects, okay? And of course, the Access Lab, we have about 10 to 15 members, about 6 of us, if I remember correctly, all have PhDs. The rest are graduate students, PhD students. And we have the MS in Data Science program. Every cohort, we have about 60 to 70 data science students who are very passionate about working on real world projects. So this is really good because, again, we lack data science talents in the country, right? So where will the enterprises find these talents? So at least we get to somehow address that particular aspect. So the two kinds of engagements that we have at Access Lab is first, directly the stakeholders directly working with Access Lab on R&D projects. The second engagement is our stakeholders working with MS in data science students as part of their thesis, if you will. We call it capstone projects, and with Access Lab acting as mentors. Okay, because once you work on real world projects with external stakeholders, it's very important that you don't disappoint them. Because if you do, then they will be disillusioned on what AI can do for their organization. So the main difference here as well is the price. For our engagement with enterprises directly coming from Access Lab, a company would be paying about 150 to 200,000 US dollars for a 6-month project. So that's about 10 million. And if they choose to engage us with our MSDS students, so this is somehow, in a sense, academic, not purely industry consulting, they would still pay. And they're willing to pay. Because again, they know that this is the only way to go if they want to be competitive in this particular field. So for every use case they submit, they pay 10,000 US dollars, right, for every project. So how does the process of engaging industry look like at AIM? We have, there are 5 steps here. The first one is, of course, the call for use cases, okay? Our industry development officer will release this call, and he will start meeting with all of the companies and helping them understand their business problem and helping them translate this into an analytics artificial intelligence problem. That's not easy to do, okay? But that is a requirement. After we've collected, now we're on step 2. After we collect all of the use cases, now the professors in data science would review all of these use cases, because we have to make sure that they're not too easy for graduate students, but also not too complex or difficult for a 4 to 5 month project, because our students need to graduate anyway, right? So we have to review, rescope, reject, accept, right? But the step 3 is, after we've filtered in all of the viable projects, we now present all use cases. Typically, we would have on average 20 to 25 R&D projects from industry, government, and other institutions. We present them these to the class with about 60 students, okay? And then students will start to form groups, maximum of 4 members per group. So that's the 4th step, right? They get to write proposals. So for example, if you're a student and you see Facebook, okay, so this is a bit of an exaggeration, but we've had Citibank, for example, like more famous companies submitting their use cases. As a student, if you're thinking about your career prospects, you would want to have a consulting project with a big company, right? So you as a group, as part of a group, will start writing proposals. Typically, our student groups would choose about 3 to 5 companies to work with. Of course, only one will be chosen, right? And they would have to defend their proposals. And there's the 5th aspect here, the awarding of the projects. And this is when the actual research begins. This is how a typical proposal defense looks like. Here, actually, the one facing the The front is Joseph Ladion. He's CEO of a BPO company that's based in Cebu. He's listening to one of the proposals, and then he gets to choose the proposal. Okay. And then after that, students would now start to work on this industry project. Even this part here is very exciting for all stakeholders, right? And you can see here that students really need to speak the language of business during this part, because it's not just about the model and how they envision to solve the industry problem, but also how they can articulate the impact of their approach. And the next slides are just some of the examples of projects I've covered. For one of them, I cover the logo because we cannot really share them because of NDAs. So in 2020, this is an example. We started in 2019. I'm going to show you the numbers for the very first time. But in 2020, we received more than 25 use cases. Imagine that. No? Unfortunately, of course, we only have a limited number of students. We only have a limited pool of data scientists. So we only got to solve and accept 15. All the other 13 use cases, we had to turn them down. Okay. Not because they're not good. One of the reasons as well is that students weren't interested in some of the projects, or there were more interesting use cases for our students. See, so all 28 were presented, but then we only received 15 proposals, okay? Proposals for 15 use cases. So that's an example. So where are all of these proposals coming from, right? You would think, oh, in the Philippines, I didn't realize that, a lot of enterprises and organizations are actually interested in AI R&D projects. The problem is that they just don't have the capability, right? So again, this is a great opportunity for a lot of academic institutions out there. So these are the numbers. Again, this is the first time I'm presenting this. MNC stands for multinational company. These are really big companies that have presence in various parts of the world. We've also worked with nonprofit organizations, the BPO industry, government, right? You will also notice here, everyone, that there's this academic bar there. The reason that we have an academic research is that not all industry projects are 100% successful, because they're real world projects. Sometimes stakeholders will have issues on data access, for example. I can elaborate more on that later if we'll have time. So, but then our students would still need to graduate. We need to know how to pivot, okay? And we have to provide them with a big data and cloud computing AI project for their theses, because there's some problems with the engagements. I'm going to discuss that very briefly later as a risk in this kind of engagement. What are the topics? I said earlier that artificial intelligence cuts across industries. And you can also see that in our corpus, right? So you can see that we have projects in the lots of projects in the education sector. These are sponsored by government, foundations, and private institutions. We have, of course, projects in the healthcare industry, manufacturing. This is expected with the fourth industrial revolution, marketing and sales. Again, all 39. This is a lot of R&D projects that we have to manage in just 3 cycles. So meaning MS in data science 2019, 2020, and 2021. In the current batch, 2022, we need to collect 17 R&D projects to work on. And I'm going to put that later under the box of challenges that we are facing. So how does the process look like? This is for our students here. Of course, we start with the use case. This is the question. Most individuals, when they hear artificial intelligence, when they hear data science, they immediately think data. I have this data. What can I do with the data? But that's not how it works for most organizations, especially those that are not yet at the very mature level wherein they can just innovate, right, from what they have. So you start with a question. and understand what the value of asking that question is. Okay, why are you even solving that problem? Then after you ask the question, it could be a business problem, it could be a society problem. You have to cast it as an analytics problem. And then you can check, do we have the data to solve this? Okay, you collect the data. Sometimes it's incomplete, right? Sometimes they have different granularity in terms of space and time, but you have the data. You perform exploratory data analysis. Typically, this is just your summary statistics for our students here. And after you do that, then you start building the models. This is where artificial intelligence as a field really comes in. Sometimes we even have to borrow other methods like in complex systems, in network science, right? Because again, you're solving real world problems with no obvious solutions, okay? With unique solutions, with multiple solutions as well. After you have the modeling, there's the interpretation of the results, making sure that they are translated back to the language of your stakeholder. And it's an iterative process. This is R&D after all. Then, of course, once everything is good, you now communicate this, and hopefully it helps in the decision-making process of your organization. I'm not even going to cover here the deployment aspect, which is also very, very important. Okay, but these are, but the prototyping is also an important aspect of an R&D project with the industry. So some projects, I'm just gonna go through this very briefly because I'm actually timing myself. I still have approximately 15 minutes. At this point, again, I mentioned that I didn't want a monologue, so feel free to raise your hand. I actually have 3 screens in front of me, so I can see if you're raising your hand. Type your questions in the chat box. I can also see that it's also in front of me. So yeah. Now we look at the projects that we've worked in. This is just one example of AI in agriculture and also in manufacturing, because in this particular project, we work with a conglomerate in the country. They have over 60 outlets spread across the Philippines, okay? And one of their biggest issues is spoilage. So they manufacture these feeds, right, for the animals. So if nobody buys them, then it gets spoiled. They lose a lot of money. So we built machine learning model. In fact, this was on my part unexpected, using a deep learning algorithm for this particular project. It showed to be to give us the highest accuracy compared to the other more traditional machine learning models. And according to the CFO of the organization, they're able to reduce costs by 100 million pesos because of this project that's done by our students under the guidance of Access Laboratory. Now, again, this is something that we are very, very happy to witness. Another project is with the manufacturing industry. This is on predictive maintenance. This project is actually with a multinational company. Imagine you are a student working as a consultant for a manufacturing Fortune 500 company, right? So here the problem is on the machine-human interface. They want to maximize the output of that machine, but people get tired, right? People get lazy. If we're not feeling well, we won't be there to use. So the company won't get to maximize the capability of the machine. So here we built models as well to help in the scheduling, for example, and also to suggest periods wherein you have to perform some preventive maintenance, okay, in the factory. And here again, according to our stakeholders, the numbers are not coming from us because the business value has to be clear. They're able to save about 75 million pesos for 1 year for 10 products. But note that the particular device that we are actually focusing on in this project has over 90% global share, okay, in the market. So we are really talking about millions of dollars in savings here per annum. Again, this is just an academic project in collaboration with industry. So another example is AI in smart governance. This I can share with you. This is with the BSP because they've presented this particular project in an international conference with various central banks all over the world. So what's happening here? The Bangko Sentral ng Pilipinas is a regulator. It reviews about 500 financial accounts every month. And for each financial account, they would spend about 40 man hours, okay, to look for, pattern breaking phenomenon. I don't want to use the term anomaly, but let's just say pattern breaking phenomenon. So they do that 40 man hours. So if you have 500 accounts, you actually spend 20,000 man hours per month. BSP sent in their own employees as scholars of the MSDS program. The employees, Rose Amodia, Santo Domingo, Soriano, and Orencha, I put their names here to acknowledge them under the guidance of Prof. Monterola and also the Access Lab. They're able to build an AI model that's also powered by network science that could do what these humans do. And we're able to reduce the processing time from 20,000 man hours to 11 minutes. Same task, right? That's 99% reduction of processing time. Another example is in healthcare. This is with another multinational company, but is Philippine company. Okay, so they wanted us to perform some prediction, the hospital capacity, the beds, right? You have to understand the kind of disease, how long a patient stays so that you can maximize and optimize the resources. And because of the project, they're able to save about 15.3 million per annum per 10 diseases. Okay, so again, it's not just about working on an AI project. It's also about knowing how to communicate to the stakeholders and speak their language, from numbers to their language, right? What does it mean for them? And this is last example that I'm going to give you because this is very timely. I saw that Carmi, she's the one leading this project on the NEDA end. She's a proud alumna of the MSDS program. Yes, our government agencies have data scientists. No, we help them build this algorithm to build a contact network for the tracing pillar of our pandemic response. Okay, I'm going to give you a result. So ideally, for every infected case, that's the first set of figures here, you should be able to contact trace about 30 individuals. If that person is moving about, right? Of course, if you're just staying at home, you will not reach 30, but ideally on average, for every contact, you should be able to list about 30. But in the Philippines, this is in an August 2021 data. They're only able to do 1 person is to 6 potential contacts. And this is just like 1 household. It's really terrible out there. So NEDA came in, worked with stakeholders together with the Aboitiz and AIM data scientists at Access Lab and our alumni. And guess what? We're able, using artificial intelligence and data science, we're able to improve the contact tracing ratio for certain LGUs, okay? Because we didn't work with the whole country yet, because this is prototyping, to improve from 1:6 to 1:116. And the algorithm also allows us to focus on more vulnerable individuals, right? So that's 1:29. Again, this is something that we're also really proud of, because this is not just working with the industry, but this is really your 360 multi-stakeholder project and led by our alumni. So that's really something that I'm very proud of. I'm almost done. Now I want to focus on the return of investment, just to recap everything of doing this industry academia engagements, right? The return of investment, we've had 3 data science batches. I'm not even talking about the first type of engagement, just the second type of engagement. In MSDS 2019, according to our stakeholders, the total potential revenue was at 10 million US dollars. This is just, I think, for 10 projects, if I'm not mistaken. And then for MSDS 2020, we were really so shocked that the potential revenue, because of the data science and AI projects that we did for these stakeholders, reached about 40 million US dollars. And then for the latest batch, it's $28 billion, million US dollars, yeah. But here we are not even quantifying the societal impact for the last project, because in the last batch we had more projects coming from the government, okay, the military and also CHED. Okay, so that's why we cannot put a dollar there, but there's a lot of developmental value. That's why in the second point here on the return of investment, there's both the social and developmental impact. And when I talk about developmental impact, it's not just your typical development kind of output, but really developing as well this R&D culture with the enterprises, especially the small and the medium enterprises, right? They get to see the value of doing science. They get to see the value of having an analytics culture in the organization, how it can help them in their decision-making process, even if the project is just a small project. And finally, of course, we are still an academic institution. So it's a very good way for our students to be exposed to actual consulting projects as scientists. So here they get to experience real world sandboxing, meaning they get to play with actual projects, but then there are mentors who are there to help them if they mess things up, or if they get stuck because it's R&D. Now, on the challenges. So these are real challenges. Hopefully PAASE can help us. We can help each other, right? One of the challenges that we saw in the last 3 years is really the lack of an R&D culture in our organizations outside of academia. When I say lack of R&D culture, it's not about not appreciating it, but really not understanding what it's all about. What are the expectations? Some of the questions that we would get in our scoping would be, what if the results are just a verification of what we already know? Is it really worth doing research on? These things are difficult to answer. I say that we lack an R&D culture because I worked in Singapore for 6 years, and it seems like it's really part of their language, both the government and the enterprise, but it's different here in the Philippines. So you really have to handhold organizations, align with their expectations. You also have to explain to them that whatever results that we give you, it's just one of the results of a range of possible scenarios. You have to be very clear on that, because if not, they will take it as something final and exact, and they will decide based on that. So you have to be very clear on that one. And of course, there's also the issue on intellectual property, right? Then the second is data gaps. Some companies don't even know what kind of data they can share. Now, we've had engagements wherein we sat down and then they will tell us, also, we have this data, that data, we can get this for you to solve the use case, because that's part of the scoping. During the scoping, we asked them of their use case. And on top of asking their use case, we asked them if they already have some existing approaches or models that they use in the organization, so that we'll just build on them. And also the kinds of data that they have, if they have access. So then they would list all these. And we will just trust them. And this is one of the reasons why some of the projects don't push through, like what I mentioned earlier, because after we start with a project, that's when they realize, like, oops, wala pala kaming data. We don't have data, or we have the data, but we don't have access because IT won't let us access the data. That is a problem, right? Because it means that our students, they need to graduate on time. So we need to have some backup projects. We need to be able to pivot. Project risks, very high as well, because again, it's a 4 to 5 month project. There's a lot of moving parts here. And this is why Access Lab is very necessary in these kinds of engagements. So if students don't get to deliver because they just can't, Access Lab takes over. Because again, these involves time and money. And if we're not successful, we are really not helping in terms of, you know, communicating the value of artificial intelligence. Our worry is that companies might feel disillusioned on what AI can do, especially if we will not deliver. We do not want that to happen. Another challenge in scoping activity, it takes a lot of time. Just filtering in the projects, just translating the business problems into analytics problem would take maybe around 2 to 3 meetings, and every meeting would last about 2 to 3 hours, depending on the level of understanding of the organization. So this eats up a lot of our time as well, especially our industry development manager. And of course, the fifth one is really the lack of mentors who are practitioners. Again, if the students aren't able to deliver, as scientists, we should be the ones who are able to deliver eventually. The students will just get lower grades, but we do have an external stakeholder that we also have to take care of, right? So we have to make sure that we can also do all of these projects ourselves. So these are the challenges that I think you saw the opportunities, lots of them, but these are serious challenges that we have to overcome. And as the program gets bigger and bigger, these challenges would also scale. So if I have, okay, so I'm just gonna open the floor to questions, and I think I want to end there. So I'd like to thank again PAASE for having me. Looking forward to hear your questions and feedback. Thank you. Thank you, Pros.
Thank you very much, Erica. So now we can entertain questions from the audience. I'm allowing you to switch on your microphone and camera. Anyone? Let's see if there's there questions.
This is a very shy group.
So if you're shy, you may just type your questions in our chat box so I can read them, or Erica can read them. Anyone? Okay, maybe I can be the first one to ask a question. Oh yeah, sure. Al. Yes, please.
Al, you're on mute. Hi.
You're
okay.
muted.
Can you hear me?
Yes.
Yes, perfectly.
Okay, thanks. I'm sorry, I'm double zooming. I have an event at 10 a.m. But I wanted to ask Erica, what's the biggest challenge? Because we've been in this same ecosystem for the last 7 years, for me at least, trying to get industry and academe together, industry, academe, and government. And it's very interesting that you're able to address the issues of industry to engage them, and to me that's the most challenging because they're so diverse. And being able to utilize academe and specifically AIM to form the team to respond to the needs of industry, which is very elegant in the same in a way, being able to get paid for it as well. To me, that's the challenge of being able to complete the team and address the issues. But the more important part to me is really being able to assure quality of those teams to be able to deliver, because some of the interventions, even if you have clearly seen it in the data, assuming that there's data, how long before those results that you presented today took before you've demonstrated actual results? Because I mean, you're constricted within the space of your instruction, say a year or 2 years. Were you able to get the impact of those recommendations? What's the shortest and the longest, and what's the likelihood for our people in the audience today that if they engage AI in their respective ecosystems, maybe give a good ballpark in terms of being able to see when to see the results, what can be expected, so that not only to temper the expectation, but also to give them a real clear indication that Just like for me, I mean, in my hard sciences, in agriculture, health, and it takes time. My product development cycles are 3 to 5 years.
You're right.
So in AI, maybe you can give us an idea how long that will take. Thank you.
A very good question, Al, and very tough to answer. But before they even come to us, Al, the use cases, the business value is already very clear in the heads of the stakeholders. So that's one of the advantages. We don't have to convince them that this R&D project is actually useful for them because they already come knowing the value. Now, that's why they're paying money. Now, whether or not we get results, that's another story.
There's a user need. I agree.
Yes,
Yeah.
that's another story altogether. Especially we've had instances wherein the results were obvious to them, right? But what they don't understand is that now this is backed to data, and their initial understanding was just from a hunch, right? Maybe I would say about 80% successful, 20%, yes, we're going to deliver results, but it will not resonate, right? That has happened as well. But before we accept any use cases out, we really talk as scientists, as NAST members, and as professors. Is this something that we can do ourselves? Like, for example, if students get lazy and they start to not deliver what we need of them, we should be able to really do these ourselves. No, that's really a promise that we make sure before we take on the projects. We should be able to jump in and solve it ourselves, and the students will just get the corresponding grade. They might not even pass, no? And what also happens, Al, is because we have Access Lab, we get to meet the students once every 2 weeks. You cannot just leave them and not check on them for 1 whole month, because projects last from only 4 to 5 months, and it's R&D. Now, so that's some of our hacks. They're not perfect, but somehow we're still here. So I guess they're a good part.
Now you're doing a great job. I mean, you have more customers than I've expected. So it's very good.
Thank you, Al. Thank you. It's a community work talaga.
Thank you also, Erica.
Thank you. Thank you. Thank you, Al. Yes, we have Dr. Concepcion.
Yes,
with a
Erica,
question.
thanks. I've sat in some of your thesis presentations for the
Yes.
MSIP, and I just wanted to know, in order to move S&T or knowledge-driven economic development, how would you ensure or guide your students to make good use of quality data? So data would have to be accurate and also complete for you to make a good analysis and insight of it. So that's, I think, an important issue. It's related also to ethics and also to how you would like the stakeholders in society to make good use of data science and AI. So would your students who are looking for the best jobs in the Forbes 500 be kind of impartial, objective about the data use of, considering that they are aiming to be, employed by these top companies? So thanks, Erica. You're doing a great job in AIM. I've witnessed it. Thank you.
Thank you, Ma'am Giselle. Actually, whenever we're asked questions on data and data governance, the next speaker is actually the better person. I'm not so sure if Steph C is already here, no? But this is really her forte, especially working with the enterprises. But you're right, Ma'am Giselle, data is a big issue because, like what I said earlier, there has been an instance wherein we work with a large enterprise. You would think that they're already quite mature in this particular space, but then they're surprised themselves even that they don't have access to specific data sets. And if they have these data, the granularity is not what they would expect. It would be different in terms of time. It would be different in terms of space. So really, this is where education comes in, po, no? Education and use cases, successful low-hanging fruit that they have to see, because keeping data is very costly. You have to pay for space, you have to storage, I mean, and you also have to pay for security. So if you're not going to harness the value of data, it can be very costly. That's why you have to emphasize as well to the stakeholders, constant education workshops, talks, showing them the real value of data. I think this is the only way that we can really help in terms of improving the quality of our data sets. So that's one. The second one is that we have actually been having talks with the Freedom of Information organization under the PCOO. And one of their challenges as well is that, okay, Erica, we're collecting all of this data, but it seems like not everyone is interested. No, parang walang gumagamit. This is government data. And again, one of the reasons here, I think kasi it has to go hand in hand. Not everyone has the capability to perform even the simplest analytics. So my advice, one of the suggestions I gave to USEC Carla Bland is to have some small projects, even descriptive analytics, build dashboards from their data so that the stakeholders, meaning the government agencies, get to see the value of them collecting the data sets. No, it's not just about collecting data kasi. It's really like what I mentioned earlier. It's about driving insights, actionable insights as much as possible. So ang academia po talaga has a large role to play here in terms of communicating the value of making sure that you have good and high quality data and also getting the value out of the data.
So, Erica, just one final comment, and then I know we're pressed for time. Is that if it is for MSMEs in the agriculture, manufacturing, aquaculture, fisheries sectors, we know fisher folk and farmers are the poorest in the country, and we're aiming to come up with inclusive socio-economic development in the country. So we'd like to know how scientists, young ones, especially in STEM, could help gather chemical, agricultural, environmental data that would be made use of by your AI scientists. So that's a challenge.
It's really challenging po, no? First, of course, we need to have the resources. This has to be, if we want our students to be involved, this has to be part of the curriculum, no? We have to face it. We cannot just get volunteers. It has to be really part of the instructions. And constant communication as well with the communities, because you cannot just go there and start collecting data. No, there has to be a proper coordination with them, and that is the role of the universities as well, from my point of view. So the students will just get instructions on how to communicate with the fisher folks, with our farmers. But then at the end of the day, academia plays a huge, huge role in making sure that the expectations align. Ma'am Giselle, we have had an FGD with farmers, when we crafted the National AI Roadmap and fisher folk. And ang sabi talaga nila, I'm gonna say this in Tagalog, no? Ang ginagawa lang naman ng researchers, pupunta dito, tapos magpapublish ng paper, and then wala naman kaming nakukuha. Parang ganun, parang masaya na raw ang researchers makapublish ng paper, and hindi na sila binabalikan on how these papers can actually help them. They do help them in the process of collecting all of this information, but then wala talaga silang nakikitang value at sila mismo on how it affects them. Kasi nag-end up sa publications, no? Which is good, pero para sa kanila, ibang countries daw yung gumagamit ng research outputs ng mga Filipino scientists. They even cited Taiwan, looking at our data, looking at your models, pero sila daw mismo not impacted. So I think malaki ang role ng scholars and ng PAASE and NAST in making sure na properly aligned lahat ng expectations. And our students will just follow our lead.
Kaya nga, Erica, admirable talaga ang AIM for your programs, because I witnessed how you're guiding your students towards corporate social responsibility, and you're like serving as adapters between academe and small industries.
Thank you po. Thank you, ma'am, to be coming from you.
No, seriously.
That's huge po. Thank you so much, Ma'am Giselle.
Yung mga projects ninyo.
Sa mga bata dito, I want you to know that Ma'am Giselle was actually my mentor. She really taught me scientific writing when I was still a student at UP Diliman. Salamat po, Ma'am Giselle. Learned a lot from you too.
Outstanding PhD graduate of the University of the Philippines, Diliman College of Science. Congrats, Erica.
Thank you po.
Okay, thank you very much, Erica. We have several more questions, and I also have my own question, but we have to move on. We have to listen to our next speaker. So our second speaker is a data scientist and founder of Thinking Machines, a Southeast Asian data consultancy firm that helps organizations like UNICEF, Globe, and others make better decisions using their data. She has a breadth of experiences building data teams at tiny startups and at Google. She will be speaking to us about the different careers in business and technology that fall under the data science umbrella, and as well as sharing tips for getting your first job in artificial intelligence. So please welcome Stephanie C., who will talk to us about careers in data science and artificial intelligence. Stephanie?
Steph, you're on mute. Hi.
Hi, everybody. It's an honor to be invited today, and now I have to follow Erica. So, but it's wonderful to be in this community. I've actually missed talking to the people in data science community. We've all been really in a weird, very strange, almost 2 years now, all of us. So it's good to reconnect and really talk about the things we care about. One of the things we care about, which is how to build the data ecosystem in the Philippines. So let me present something. I'm going to talk for about 20 to 30 minutes about my observations coming from industry. So I think if Erica provides a truly excellent point of view on the intersection of industry and academia, my focus is much more on industry coming from the perspective of a startup and consulting organization. So here we go. All right, do y'all see my screen? Okay, I am going to assume like no screaming means yes. So
Yeah,
my
we can see it.
maybe very briefly, my career journey has taken me to a few interesting places in the overall field of data. I stopped calling it data science a few years back when I realized that the data profession touches so many things, and some of these things are more experimental and scientific in nature, and some of these are much less, but they all belong in the same core, like really big ecosystem. So I started out getting my undergraduate degree in management engineering, actually, with a focus on statistics. Really enjoyed it and was pulled into this world of technology startups. If you graduated college in anywhere in like California in the 2010 era, the big trend at that time was to start or join a technology company working on social media technology, mobile apps. That was all very new at the time. And so I joined, I started a startup, raised some funding. It failed. That was a very interesting life experience for me. I joined this company called Wildfire as employee number 12. And during the time I was there, we grew to 400 employees and eventually we got acquired by Google. In a lot of ways, I'm the opposite of Prof. Erica. I tried to drop out of college to join Wildfire. I didn't even want to finish my undergraduate degree, but my mom said, please, you cannot, you must get at least one degree. So I said, okay, Mom, okay, fine. And her point was very, very good. Her point was that if I went to the startup and succeeded, I would go on to do the next thing, the next company, and I might never be motivated to go back to go to college. And she was not going to have a dropout as a child. So that's why I ended up finishing my degree. Thank you, Mom. So I did join this, I did finish, get my degree. And at Wildfire, when you're a small company, when you're going from 12 to 400, you do everything. I was technically hired in as a analyst, but in my time there, I worked to help the business make data-driven decisions in every aspect of the business. I built a lot of our sales and leads management systems. I built a lot of our analytics systems to understand how customers used this product. So Wildfire was a tool that built that help other companies by letting them run sweepstakes and promotions on Facebook primarily. So if you ever joined a sweepstakes or any kind of contest on Facebook between 2010 and 2013, that was probably using some technology that I built. I also, because it was a startup, I also did whatever it took to help the startup succeed, like buying furniture, loading it into a giant truck, driving that giant truck down a major highway and praying that nothing would happen to me, the other people on the highway, whatever it took to get the job done. And then I ended up at Google, which was very interesting. So when we were acquired by Google, we were acquired because we knew how to handle social media data, and Google wanted to take on a lot of our expertise. So I went from handling databases that were, typically a couple of gigabytes. Typically, I was looking at millions of records and trying to run recommendations, exploratory data analysis, or a machine learning model to recommend the next best action on 3 to 10 million customers. At Google, that's a sneeze, right? So Google was very interesting because that's where I learned how to build infrastructure at much larger scale on the cloud and serving other developers. So you have to build infrastructure for people who you don't meet at that organization, which is very interesting. It makes you very disciplined in how you think about the data you have, shared definitions, APIs, and how to get data to other people, and basically how to work with much larger infrastructure. And after about a year and a little bit of doing that, I quit the job because I had vested, they have golden handcuffs. When you get acquired by a company, if you're so lucky to have that happen, typically they have, they'll try to keep people on for up to 4 years and with golden handcuffs. So after a year and my golden handcuffs had expired, I decided that I wanted to try to come back to the Philippines and see what can be done here in the space of data. Because what I learned at Google is that you don't need a lot. You don't need land. You don't need a huge capital investment. You need computers. You need cloud computing. You need smart people to start effective startups and businesses in the field of data. So I thought to myself, okay, well, the Philippines has no shortage of talent. Let's go. Let's go and see what's possible. And 6-7 years later, here I am. So I will be talking primarily about the industry track, startups, strategic consulting, building data teams at building data products at more established corporations, and also building distributed products. So maybe more of the open source, open data world. Industry is very different. So when I have some people joining Thinking Machines who come from who out of school come with this mindset of I want to build something cool and I want to build artificial intelligence. And actually the first big learning that they need to embrace is that to succeed in a data consulting organization, it's not about the model that you're building. It's not about the originality or difficulty of the model you're building. It's about the value you're delivering. And sometimes an Excel model can be far more valuable than a classifier. I'm going to say that one more time. You have to build what's useful to succeed in industry, not what's shiny. So I think I have disappointed several people who graduated with master's degrees who come to Thinking Machines and go, oh no, why am I doing janitorial work? So my title inside the company is head data janitor, right? And really that's how I see my role and in a lot of ways, the role of industry. Industry is here to deliver value to our stakeholders, our customers, and our community. Industry should have a broad and pragmatic scope, focused on solving problems at scale for users. And you have to work well with other people, other organizations. So if you're inside a company, you have to work really well with the product team, the engineering team, the business team. If you are in the world, right? If you're a consulting organization like Thinking Machines, you have to work really well with customers in different industries at different levels of maturity. And you certainly don't need a PhD to succeed, though industry experience in a specific narrow space you're operating in, sometimes that's telecommunications, sometimes that's banking, sometimes that's crypto, which is a very interesting new space. for data companies to grow in. So that is quite valuable because then you understand the causality, the rationale, how the system works, and how organizations use data to make decisions in it. One thing that I found very difficult when I first came back to the Philippines is that I found the ecosystem trapped in a very low quality local maxima. I have put it down here. This is very rough. And this is a little bit controversial. So if people like disagree with me in chat, I'm so happy to take disagreement. I love arguing. Not really. I love discussion. So I'm like very open to like talking about this. But my perception is that these four categories, you have the educational system, you have the tech companies, you have like the companies in general, industry in general in the Philippines, and you have civic society. We're all trapped in this very low quality local maxima where every time somebody inches upwards, they get pulled back down just by the factors affecting like the other parts of this, because a healthy ecosystem is one where these four all support each other, right? Great schools produce great students who then can join tech companies or join industry to build data systems, and the tech companies can sell these products to the established companies, and the startups can grow, and then all this becomes like a net positive to society because customers and citizens are impacted by good decisions made. We are in this very bad equilibrium where schools are kind of trapped. And this is why I actually admire AIM a lot for finding a way to dodge the traps here. Because schools have to think about, one, do we want to produce high quality research? All right. If we do, and if we track our students in that direction, can the students then cannot find jobs at companies here because tech companies at that scale don't exist, and industry doesn't really understand the value. It's like not mature enough to understand the value that these high quality students bring. So these students end up working abroad. They go away, they exit the ecosystem, which is a net, I think, negative to society. Or if schools focus too much on vocational work, if you look at vocational work, it's very interesting. I've been in meetings where the question is, how do you retrain 500,000 Filipinos? And I'm thinking, oh my gosh, I know what to do with 5. What do I do with 500,000, right? So the only way you can handle that is by thinking about where can we take 500 jobs and add it to an existing pool of like a million jobs. And the only place that can happen is BPOs. But BPO work is very, very structured, right? So you end up with schools that produce students who know how to do very narrow things very well, but outside of those narrow things, where that narrow thing might be an Oracle or SAP implementation, they do genuinely have difficulty. But that's what's employable. This equilibrium is really bad for tech companies because tech companies, if there's no area of focus and if there's no companies willing to take a bet and like buy tech products that are scalable, they then end up with like unscalable products and slowly starve to death. So this is where I sit really, the challenge that I faced when I started my company. Typically, the way to do this in elsewhere in the region or in the US would be you raise funding, you find a specific problem where tech can scalably solve that problem, you raise some venture capital funding to build a solution to that problem, and then you work with companies, and companies as your clients will buy software as a service from you, and that's how you scale and grow. In the Philippines, the problem there is when tech companies start to succeed, they hit this problem of companies not being mature enough to procure their products in this like integrated software as a service kind of way, because the companies themselves, they are trapped in this bad local maxima where they want to innovate. Companies want to innovate. I've been hearing for 500 million years about how companies want to become data-driven, digital first, etc., etc. And that's nice to hear in talks. But then what happens when you hit the cold hard truth of, okay, will you hire students? Will you hire companies? Are you going to invest in this? What are you thinking about this? As Erica was sharing, you have to think about their use cases, right? And what they do and how do they solve problems and how do they use data to solve problems. There's a level of maturity in these companies that's not quite there yet. And because they're not there, they're not willing to invest because they're not quite willing to invest because they want to see ROI on every peso. But the problem is, innovation means that you sometimes fail. You're not going to get ROI out of every single peso you put in. So there's like this fear factor going on there. And all of this is bad for society because without this ecosystem, we end up limping along. We end up with slow, poor quality decisions with bad data. So that was a very depressing 5 minutes I just went through. What can we do to break the wheel? And I'm gonna warn you that this is just like my opinion, and my opinion only. So this is a little bit what I'm doing based on the 5 years of work that I've put into thinking machines, but it could be completely wrong. So there's 6 things that I've really focused on in the hopes of breaking that wheel. So first, and this was like the hardest for me to embrace as somebody who thinks that AI is like really fantastically cool and really game changing. The first thing is to focus on building useful groundwork for data-driven decision making, meaning focus on data warehouses in Excel over artificial intelligence. So these days, every time somebody comes to me and says, "Hey, can you implement AI for my company?" I go, "Wonderful, absolutely wonderful, fantastic. Can you show me how you use Excel right now?" And all the time, you find that companies are trying to jump to AI without first building the foundations of data governance, understanding what data they have, understanding what information they need to make decisions for their organization. They don't have automated syncing for their data sets. They have data silos. They don't have a cloud data warehouse. So all of this construction work, all of this janitorial work, it's easier to understand than AI, and frankly, the ROI is much more, I think to me, like you end up building faster and much more clearly than AI. The downside is it's not AI. The second thing to do is to focus on open source and open data. And particularly when I work with government organizations or civic organizations, there's a tendency for projects to build, and then after the final presentation or after a small unit starts to use it, it kind of fades away because some undersecretary has quit, died, become politically anathema. So, oh my God, like what happened to all that work you just put in? So I think that building resilience into our research systems is very important. And so building things in the open, building things that are open source, building things that are open data makes sense because every time an open data set is improved on somebody else can come in and continue working on it. So instead of starting from scratch every time, you just build one step at a time. So in Thinking Machines, our work on AI on satellite imagery, quite a lot of that has been made open source, and we're very glad to see. It's funny, I'll get an email every now and then from a student or a postdoc or trying to asking questions about our GitHub repository. They're running into some problems. Could we help them and troubleshoot? It's always very nice to see that because it's nice to see your work being built on. Next is luring back expat Pinoy. So I think there might be quite a few in this crowd to be lured back. The thing that's very interesting is that the students who leave the Philippines, because there are like better work opportunities in a lot of ways outside of the Philippines, eventually they become skilled senior professionals who can start things, who don't need to be mentored and trained, and well, not as much, right? I think growth is a lifelong endeavor, but they're much more able to conceptualize a bigger vision, strategize, and like run for it. And so those are the people who, even if they're only here in the Philippines for 3 years, even if it's 1 year, 2 years, 3 years, getting them to contribute is a huge deal. Next is picking a role and committing to laser focus, right? So I have chosen the role of building a really passionate community of data professionals and focusing on delivering useful groundwork for data-driven decision-making for companies. That's very much not like an academic role, and it's really about like picking your role, focusing on your role, and like working with other people, working with the community, remembering that you're part of the community. You don't have to do everything. Next is doing things that don't scale. So this is something that's really hard to hear for people more in the startup world, right? You want to do things at scale. But if you're trying to change a system, you sometimes have to pick fights where you do really, really gritty, really messy things because nobody else will do it. So I think a perfect example of this is cleaning data sets, cleaning really important data sets. If you have not yet heard of the Move as One coalition, I would recommend that you look them up. I think one of the more powerful things they've done in the last 2 years is this is like a civic data organization. One of the very useful things they've done is cleaned and like labeled a few years worth of government procurement, government contract data sets, and made it open and available for other people to use. So cleaning that data manually, like one by one, instead of writing code to do it, they couldn't quite. Writing code to clean that data set got you 70% of the way there, but they did the next 25% manually, and that ended up being incredibly useful. And then last, right, and this is why we're all talking today, it's about building a community of passionate people who care about society, who care about the same problems, because we talk to each other, we rely on each other. It's just like a wonderful thing. And ultimately, I really hope to get to this place where the Philippines, what if the Philippines could be a data science hub? What kind of ecosystem do we need to build, and what is the role that each of us can play in this ecosystem? All right, that was, sorry, that took a little bit longer than I thought. I actually want to spend the next 5 minutes, sorry, I have until 10, right? Did I just use up all my time? No, we started late, that's why we're doing this. All right, let me talk a bit more quickly about how the different careers in this data ecosystem work. So now you've seen like the big overall ecosystem. Next is within the world of like data, what kinds of jobs exist. Backing up a bit, this is again in the context of my company, which is a data science technology company. We transform organizations by building data systems, and we're very focused on doing it on cloud data systems because those are available to everybody. Not everybody can buy, a supercomputer. So if you don't have a supercomputer, what do you do? So that's where Thinking Machines comes in. We're very data driven. We're very curious. We're very customer obsessed, and we really think about building infrastructure. So it's maybe another thing that's a bit different from us versus academia. We really think about, all right, like how do you build this data infrastructure on the cloud and continue using it? I believe in a very holistic approach to building data capabilities in organizations, that you have to start with the strategy piece, right? What are you trying to do? And once you find out what you're trying to do, then you think about engineering, storytelling, and machine learning in this loop, right? Because you need engineering, data engineering, to be able to get your data sets, ingest them in an automated way. You need data visualization tools, and you need to be able to touch your data, see what's going on, have people with domain expertise be comfortable handling data even though they don't have advanced coding skills. And then once you have that loop going on, then you can build, train, and deploy machine learning models, because one of the things machine learning models need is high quality training data. And often when you step into an organization for the first time, you're not going to get that high quality training data until you build this engineering and insights loop around it first. And then last, you need enablement, right? I really want to see societal transformation. So how do we do this in our day-to-day work? We look at organizational transformation. So a commitment to enable the people we work with to do a lot of this work themselves. What does it take to build a product like that, or build a solution in this way? A pretty broad team with a lot of different skill sets. So Thinking Machines' way of structuring teams is very oriented on getting a bunch of specialists working together very well, rather than a bunch of generalists who all have overlapping skills. We really look at a bunch of specialists who know how to operate in a team and having them work that way. So the roles that we have kind of span this range from engineering to analysis to machine learning. And actually, I think project managers are very important to running programs very well. So please don't be surprised. I think in many ways, one of the core reasons I've seen projects fail is because there was nobody asking the right question, and the right question is, what outcome is this supposed to drive? And then the next question is, all right, what do we have certainty around? What do we not have certainty around? How do we drive towards good outcomes given that? Let me, jump here. Oh no, these photos are taking a while to load. Okay, so if we're talking about each of these jobs, right? Each of these jobs is really huge, really growing, and constantly changing. What I have here is not a comprehensive list. I've seen the data world change a lot in the 10 years that I've been working, and I expect it to change quite a lot in the next 10 years. So take this as a snapshot of where data professions are today in industry, but not as an indicator of where things are going to go in the next 10 years. So I find that you can span the range from a business analyst role. So this is somebody who this would be somebody who graduates from college today with a degree in management, or somebody who maybe has seniority in an organization in the business domain. So they need to learn some new skills, some new tools, Tableau, SQL, Excel, Google Sheets, how to pull in data without saying, you know, make me this slide. So this is also when business leaders come to me and say, how can I retool for the data world? I tell them, well, how do you get reports right now? Do you make an analyst like go pull you some numbers, and then you look at their slides, and then you tell them, oh, that number doesn't look right. Like, can you dig deeper into that? And if they tell me yes, I say, okay, you are gonna learn how to be the analyst for yourself, and that's very possible these days. It's very possible these days to learn a few of these things, even if you are already a 20-year professional or veteran. Next, I want to talk about the analyst, the kind of business intelligence and visualization career. So this is a career that's all about taking data that is already inside a data warehouse and then connecting it to different business users and translating their needs into really useful operational data dashboards or running ad hoc analysis. So I think that this role is very powerful also right now because of one, very high quality software available in the visualization domain, and then two, different types of data that can be geospatial data sets. I want to point that out as a very powerful type of data set that can be displayed in a dashboard, where before you had to use like GIS and it was not available in real time. Next, there's the data engineers. So these are the people who process your data, get them to you, take the inputs that you have, unify the data sets across the company, and manage your data lake and data warehouse and the whole everything kind of rests on the foundation that they and the architects build. So these are actually very, very important roles that I don't want to leave off the map, because when you don't think about data engineers and cloud architects in the same context as a data team, what you end up is like a rogue data team that's completely dependent on IT and always gets mad at IT for, because IT wouldn't provision as a server, IT wouldn't do this. And I don't think that makes sense. I actually think it makes more sense to integrate these two roles onto a data team. So you have the cloud architects who do a lot more of the planning around how do you build this data lake and data warehouse, where does it need to connect to? Because that's very important in the digital age, right? It's not just about building dashboards for human readers. You have to build API endpoints for developers to use at your company and other companies. You need to pull data from, let's say, like Shopee and Lazada. You need to push data to an automated warehouse system. So being able to build, architect software that handles all of that very well is pretty important because that's one of the key outputs of a data team. The next two roles I think you're probably more familiar with: machine learning researcher and machine learning engineer. There's a really interesting trend that I see continuing into the future, where machine learning is now being broken out into the ML researchers, so the people who build the models, and the ML engineers, so the people who focus on deploying large models at scale. This doesn't matter. Optimization of your model doesn't really matter when you're handling thousands or even tens of thousands of data points. But when you're handling tens of millions of data points, and when a single cloud job could take $20,000 to run, this is where it's pretty valuable to have an engineer with a specialization in machine learning who knows how to efficiently deploy the model and have it deploy in an operational way. So this is the difference between one-off machine learning and operational machine learning in pipelines. And then I think I made a mistake with the last one. The data analyst role and the business analyst role, I would actually make them one in the same role there. Cool. So this is not even a comprehensive look at all the possible roles. I think I've heard arguments that are pretty compelling that you need to integrate web engineers into data teams. But as of now, I think that because web engineers primarily work on developing and deploying software on the cloud, human interfaces on the cloud, it's still like one step too far away from the data team, and you can comfortably run a data team without having a web engineer. So I'm comfortable leaving that off for now. But what I do want to emphasize here is that there's a huge variety of roles and careers inside of data, and that each one of these roles, there's a very different path to each one of these roles. If I think about my team, right? We've had business visualization, business intelligence analysts come from media backgrounds, come from media and communications backgrounds. They've come from civil engineering backgrounds. I have data engineers who come from Triple E and come from computer systems, computer science. But some are totally self-taught, and they come from. I think my most interesting data engineer didn't even graduate college. Another one worked at a brewery for a few years as a brewer, and then trained himself in data engineering to a basic level, and I came to Thinking Machines. And cloud architecture, you can't really learn it in school. You do have to learn it on the job. So a lot of people who are in this role come from a computer science background, work at places like Amazon Web Services for a few years, and then come out of it with this ability to do architecture. So it's a pretty broad range. And it's pretty broad because if you think about them in context, right? So these are roles that are looking at individual roles and contextualizing them for the organization. So where do they sit in an organization? You kind of see them fitting into either business users, analysts, data scientists, and engineers, or outside. So in a company, if you think about who uses data in a company, a lot of your users are business users. They make decisions based on the dashboards and reporting. They need to be able to read dashboards and reports, and you need to be able to act on it. So their level of data proficiency doesn't have to be that high. You can actually serve them all quite scalably. The next level is like one level deeper, right? The data analysts who work not in the consulting organization, but inside of the company. So these are the people who analyze the business trends. Half the time they work for the business users, either by directly reporting to them or by having their roles like support a business outcome. So these are people who need to get much deeper into explorations. The question that they're trying to answer quite often is why? And they need to understand the business very, very well. Then you have the data scientists and engineers, right? So this is the team that runs. If you have a machine learning model, this is the team that runs it. They are they need to be much more proficient with machine learning tools. They're typically a much smaller team than a data analyst. If I think about the ratios here, you kind of have like a 5-to-1 ratio of business users to data analysts, and then you actually have another 5-to-1 ratio for data analysts to data scientists, or machine learning researchers. So for every organization of like 100 people, they maybe only need 2 people with specializations in machine learning. You don't need to be fully. Well, even in an organization like TikTok, where they run hugely on computer vision and machine learning, that team is still just a small part of the big overall company. Cool. So this last segment that I'm going to talk about, take like a minute or two to talk about, is if for the students here, right, or people maybe earlier in their careers, thinking, hey, this looks pretty interesting. One of the roles maybe called out to you quite well. And you're thinking, what do I need to do next? How do I get there? Well, you need to learn a lot and be very, very flexible in terms of what you want to do, what you're ready to, what sector you go in to do. You have to be curious, you have to learn fast, you have to have a strong conceptual understanding of the industry. Sorry, meant to say, for the industries that you end up working in, you need to understand what they care about so you can structure and solve problems. It doesn't make sense to go to maybe let's say a power company. It doesn't make sense to go to a power company and not understand how electricity is transmitted. You will end up asking questions that are a bit too nonsensical. So when there are gaps in their knowledge, Google, phone a friend. Don't be dumb, right? And don't be arrogant either. Don't assume that because you know machine learning, you don't need to understand how data works in this specific industry. You actually have to, I think one of the really interesting things about being a consultant is that consultants who approach the job with a spirit of humility, who ask a lot of questions, who really understand what they bring to the table in terms of specific expertise, but understand how to pull expertise and knowledge out of the organizations they're working with and come in with that spirit of humility. Those are the people who tend to succeed in my space. Next, it's still all about learning, right? So here are some pretty practical texts I've found in our space. Learning about machine learning, I think, is very key. I would prefer a focus on learning the fundamentals of how statistical models work over learning how to write code in PyTorch, let's say, because over the last 10 years, I've seen like 3 or 4 deep learning and machine learning models come into vogue and fall out of vogue. And you should expect to see another 4 or 5 libraries, languages come into vogue and fall out of vogue again. But they're all just re-implementing the same concepts slightly differently. So learn the concepts, right? That way you can tool up on a new language like very quickly and not worry so much about, oh, I don't have this specific thing on my resume. I don't have that specific thing on my resume. If you know statistical learning quite well, you can always take a month and pretty much get up to speed on any new language. Understanding how data works in the world of software engineering is also very key to success, even if you don't intend on being a data engineer. I think this book, Designing Data-Driven Applications by Martin Kleppman, is like the best book of its class in explaining how, well, it's exactly what it says on the cover. There's a lot of resources on convolutional neural networks, deep learning research out there. And what I want to emphasize is that so much information is out there in the world. There are so many classes that are fully open to you. Like this is like, there's a breathtaking amount of educational content on the internet for people to access. So start with one and just keep pulling threads. Keep pulling threads to follow your interests to the point where you are able to read the papers being published at the AI and machine learning conferences. That's incredibly powerful. And then connecting to people, right? So the next 3 sections, learning open source, reading blogs and Twitter feeds, and really participating and finding a job or internship and getting into a community of experienced professionals really helps, because then you get all of the unspoken knowledge, right? The field moves so fast that there's a lot of things that maybe Professor Pross would know that he hasn't had time to write it down. He hasn't had time to write the textbook yet. And by the time he gets the time to sit down and write that textbook, you kind of missed, you could have just asked him and learned the thing 5 years earlier. So I think asking people is pretty powerful. So the last message that I want to leave everybody with is that get ready. If you want to step into the data professions and the data industry, you have to be ready for it to be, you have to, get ready for it to be a bit of a wild ride. It is really a cowboy space right now, a wild west space where there isn't always a clearly defined path to success. Enthusiasm and an entrepreneurial mindset go a long way, both looking at a career as a whole and looking at specific projects and specific organizations you're working with. Almost nothing is clearly defined for you at the start. So one of the key skills of a data professional is stepping in and turning ambiguity into clarity. And with that, you're going to make mistakes. So if you go into this field, be kind to yourself and remember that the most powerful learning you can pull up in life comes from when you fail. So don't be too afraid to fail. All right, so that's everything from me. I'm sorry, I saw things popping up on chat. I'd love to answer some questions and see what people have to say. Also keeping an eye on time a lot. Let's see. Yes, Google is our best friend. If you know how to read the sources. Oh, I have a question from Candy Bandong. Do I fail a lot? Candy, can you clarify what are you thinking when you're asking that question? Oh, Miss Candy, are you here?
I'm here. I'm here.
Yes.
I'm sorry. I was on the chat room, but I would like to ask you about your failures as a young student at Stanford or Google or an employee at Google. I've been an educator for quite a while, and I tell students to fail early so you can succeed early. What were your failures? I would like to just get a glimpse of one of the ones that you remember most.
Yeah, I think there's a lot. I think the pieces that maybe the one failure that I think was the most formative for me was when I was a college senior and I started a startup with two friends. So in Stanford, it is like a very entrepreneurial environment, and the message that you get from your teachers, from the venture capitalists around you, from like older students, like, oh yeah, start a startup. Like really young people can start a startup, no problem. Like go for it, and you're very supported in that environment. So me and two friends, we had a concept that would work. We started a startup. We even raised money for it. Like some investor was crazy enough to give three 21-year-olds with no life experience a bunch of money to see if we could build a technology company. And frankly, it's one thing to hear that you're gonna fail. It's another thing entirely to be experiencing failure. So we did a few things wrong in that company. One is we tried to build a product and we tried to bring in users first and see if we could build a business model on top of it. But we ended up building a business model that was pulling away from, that was not providing value to the people who are using our product. So we were building it was called a Phenom list. So we would try to find all the most phenomenal people in technology and profile them. And the way we made money was by, we tried so many different ways to make money. Unfortunately, the only way we found to make money was to have companies pay us to call the people who we profiled on the Phenom list. But the people who we profiled did not want companies to be harassing them with phone calls and recruitment offers all the time. So there's this like terrible tension between building a good product and making money as a business. And I think ultimately that's what sank the business. And there were so many really difficult lessons, like really powerful life lessons I had to learn there on professional maturity, communicating with stakeholders. I built a lot of the technology, and frankly, like writing that code was the easiest part of the thing. That's a lot of the a lot of the human elements that made it really painful. And in the end, after 6 months, we looked at the company, and I was like, oh my goodness. Yes, we have a lot of users, but we don't have a compelling and workable business model. We are not really gelling well as a team. And I think the experience of being able to say, hey, this is failing and we need to shut it down really was really powerful for me as a student. So definitely learned a lot of life lessons there on how to work and how to be a professional that I took into my career after that. Yeah, thanks for asking that question. It's really hard, especially for high performing students, to see that failure is okay, because by definition, the students who are at the top, 5% of your classes, they're the ones who are not used to failing, who think that you can always work work hard, you will succeed. It's very hard to learn that sometimes you can work the hardest you've ever worked in your life and you can still fail. And that's okay. You're not gonna die. You're gonna okay, and that level of entrepreneurial resilience, I think, is hard to communicate, but very important.
Thank you. Thank you very much.
Very much. Thank you very much, Stephanie, and for that question on failure. I think we all experience failure as data scientists and AI researchers, and perhaps the only way to succeed is to experience failure, perhaps many failures, and it takes a lot of grit and determination to eventually succeed. And I don't even think that somebody has succeeded the first time. Just the first model, and you're done. No, that never happens. We experience failure every day because our models fail all the time, and eventually we make it work. So that's the thing that that everyone sees, the good, the nice working models, but behind that model you have days, months of making your model work, retraining data, and so on. So although it's time for the next speaker, Edith, can we entertain one more question from the audience?
Morning,
Oh,
Dr.
Yeah.
Sure, of course.
Hello. Anyone would like to ask a question?
I see one in chat, right, about cloud computing.
Oh,
Maybe
yeah.
I can on that one because I think the researchers have access to supercomputers, but in the industry, you typically don't. Like you typically have to do everything on cloud compute. And so I actually strongly recommend. So how do I think about the cloud computing platforms? My framework for deciding what to use is one, what abstracts away a lot of DevOps for me, because when I first I'm not that old. I'm not that old. But the first time I used like cloud computing, it was all like basically like bare metal servers, still like Linode that you would just SSH into, but you have to configure and manage the server yourself. And these days, a lot of the configuration and server management is abstracted away into an interface, which is great because if you're trying to build your career in machine learning, you actually don't need to know that much about how software infrastructure or DevOps works. So I would recommend using a cloud computing platform with a great UI UX that abstracts that away, particularly for data. So I think the two strongest ones are Amazon Web Services and Google Cloud Platform. I think is yours okay? I think if you have access to it, all three of them have the same notebook environments. So Jupyter Notebook has been a very powerful innovation and works with Jupyter Notebook is a way to write code and have your charts and output render inside of that notebook environment. It's a fantastic tool for machine learning exploration and is supported because it's open source software. It is supported on AWS, on GCP, on Azure. So you really can get started on any of those. The other thing, when I look at the cloud computing environment, I'm really looking at how easy is it to get started and how badly can you mess up? I think the risk with, for me, I prefer Google Cloud Platform for students because on Amazon Web Services, the risk is that you press a button. So for example, you have access to an open data set of LiDAR data, right? So that's like terabytes of data that you're accessing. If you write your query wrongly, you will end up accidentally spending 200,000 pesos on AWS without meaning to. And that's like a total nightmare for students. I've definitely had to handle I've had to help a student, very panicked student who called me and said, "Oh my God, I have spent like here is my AWS bill. What do I do?" And had to call AWS in the Philippines, like GCP in the Philippines, to say like, "Hi, this was a mistake. Is there any way you can credit this back to the student? There's no way they'll be able to pay this." And The cloud organizations are not that responsive, so I think it's better to avoid making that mistake in the first place than having to call them. In the case I'm thinking of, thankfully, the fee was waived, but you can't count on that. So I think between the three, I actually think GCP allows you to put in more safeguards on like spending. I think Azure does also. So on balance, for learning purposes, I actually do recommend Google Cloud Platform because you are able to access a lot of data sets. They have a lot of data sets available to you for free. BigQuery, it's really easy to like explore and access data sets to do research on. And then the environment is like very developer friendly. But on production, right? So in industry, when you're working, I actually think that AWS has an edge there because Amazon Web Services is the most robust when it comes to e-commerce, all of the like new digital applications that are the most consuming the most data, driving the most value for companies. AWS supports their use cases the best. So all the data already starts in Amazon Web Services. But frankly, me as a person, I prefer working on Google Cloud Platform. It's a better developer experience. But when it comes to infrastructure and software, AWS is like extremely powerful there. So I think both are really good. The thing I don't like though is controversial opinion. I don't like Azure from a developer perspective. It's really frustrating to work with. I find myself constrained a lot, but enterprise IT organizations always prefer Azure because of the security considerations. Sorry, so this is like a long answer to what you might have thought was like a simple question. But the answer is, depending on the organization, they really have to think about their existing infrastructure, what they have to integrate with, their IT, their existing IT environment, their security preferences and infrastructure access management requirements, and then the developer and machine learning user experience is only one of 10 or 12 factors that they look at and choose. I've seen all three at organizations. I think all three work in various ways, but my personal preference is to use Google Cloud Platform.
Okay, thank you very much, Steph, for those tips and for your great talk, very engaging talk. I guess we have to move on to our next speaker. So our next speaker, our third speaker, is a professor at the Department of Information Systems and Computer Science at Ateneo de Manila University. Her areas of specialization are AI in education and educational technologies. She is also the head of the Ateneo Lab for Learning Sciences. She is the chair of the International Program Committee of the 2021 International Conference for Computers in Education and program co-chair of the 2022 Artificial Intelligence in Education Conference. She's on the executive committee of the International AI in Education Society and the Asia Pacific Society for Computers in Education. So please welcome Professor Maria Mercedes Didith Rodrigo. She'll talk to us about eye tracking for novice programmer research. Didith?
Hello, Pros. Hello, Ma'am Giselle. Thank you so much for this this invitation, and I'm very happy to be here. I'm very honored to be included. I just wanted to start by saying thank you to Steph for the very interesting talk. I was particularly triggered by the first thing you said about the ecosystem that we have that was suboptimal. I agree with you completely. And this is one of my deep frustrations as well, that I know that we try so hard to train our students, especially our PhD students, and then they all go off they go abroad because of better opportunities, because the environment here doesn't provide them with the sorts of opportunities they're looking for, or as is the case with many of my students, they do go back to their home institutions, but then they're assigned high admin positions, which are very important in their own right. It's just that they don't have much opportunity to use all the complicated stuff that they learned. So it is quite sad and frustrating, and so the talk that I'm going to share today is actually in tribute to two of my PhD students, one of whom has graduated already, and both of whom find themselves in admin positions. So anyway, I want to share their work. So to the rest of the audience, hello and good morning. And the talk that I'm going to share with you today is a little different from the talk of Erica and Steph, in the sense that I'm going to share with you an experience of using AI to understand some data. So it's a very specific case study, if you will. So it's a little, it's not, unfortunately, it's not career oriented, but it gives you a story that that maybe will help you imagine what you could do, like one of the millions and millions of things that you could do with data. So as Doc Frost had said, I'm the head of the Ateneo Lab for the Learning Sciences, and there are many things that we do, all related to education and using data science and computer science to try to improve and understand education. So the two main things that we do in the lab is, first is we develop educational software, but the other thing that we also do is we use analytics or we go into learning analytics, which is a specific application of data science on educational data. One of the projects that we had, which was funded by the Philippine Education, PEAC. I will remember the name of what the acronym stands for later on. It was a study that made use of eye tracking in order to understand how novice programmers trace and debug code. This is more or less the outline of the talk that I'm going to share with you today. So first, what is eye tracking and why do we use it? We use eye tracking we monitor eye gaze because we want to determine what people are paying attention to. So when you eye gaze is a proxy indicator for attention. So what you're looking at is what you are paying attention to. If you are looking at a supermarket and your eyes zero in on the chocolate, then you're paying attention to the chocolate. If you're looking at the same supermarket, if another person is looking at the supermarket and their eyes focus on a banana, then their attention is on the banana. So what you are focusing on with your eye gaze is what you're mentally focusing on as well. This tells us many things about how the minds of our users work. It's interesting. We can tell more or less what they find interesting, what they find attention grabbing, or what they find important. And visual attention is defined as focalization or concentration of concentration. So you take in a large stimulus and you bracket out the extraneous details and you focus on one particular thing. So you withdraw your attention from other things in order to focus on the one thing that you find interesting. And so the process of visual attention is that you first see things in low resolution, very broadly, and then when an interesting feature pops out, then you focus on it. So, for example, this is a painting by Vincent van Gogh, and there's a lot to see. You have mountains, you have houses, you have a haystack, you have this cart here, and then you have a fence and so on. And the first time you look at this painting, you can see it in broadly, but then a few moments later, you might turn off the attention from the peripheral locations and then focus in or zero in on one particular detail of the painting. So this is Tilt Shift Effect by the artist Serena Malion. And you'll see here that this is exactly the same painting, but this time there is a focus on the cart that was in the middle of the painting. So this is kind of what happens with your visual attention as well. The stuff in the periphery is blurred out, and what comes into stark relief is the object that you're focusing your attention on. So when you do eye tracking studies, you ask questions like, what are people looking at? What do they notice first? How long do they look? How long before they notice something? These are all questions that can be answered with eye tracking data. We ask these questions to get information regarding people's thinking skills and implications on design, pricing, placement, and so on. Okay. Now, let me tell you more about the project that we undertook. We were interested in how programmers understand code, and for those of you who are in computer science, you'll understand when I say that code reading is a prerequisite to program comprehension. When you read a segment of code, you don't read it the way you would read a novel. You would read it maybe following the flow of the program, following the logic of the program. But it's important. It's an important comprehension problem to understand and derive the structure of the code and not just the text of the code. If you read code as text, then you'll read it sequentially as you would read a novel or a short story. But the code, but code has a structure to it. It has there are, even though everything sort of lays out flat on a page, it isn't actually flat in terms of logic. There is a structure to the logic. So it's a very important skill for anybody studying programming to be able to understand not just the text, but also the structure of what you're reading. And eye tracking is a way that you can measure whether people are actually parsing the structure or just the text. What we did for this project is we wanted to have students trace or find or locate bugs in a program, actually in 12 programs. So we created these 12 programs that were very short. All of them could fit in one page of a screen. And we wrote them correctly at first. And then when we were sure they were correct, we inserted errors in the program. So we knew exactly where the bugs were. We started each session with a description of the problem like this, and then we made the users read the code and try to. So in other words, the users or the participants knew what the intention of the program was, and then we gave them code here, and we asked them to locate the bugs. Now these red ovals here are marks made by the participant. They essentially encircle the areas where they think the bugs are, and the yellow line here, that's the eye tracking trace, which I will talk about later. We conducted this study with 6 universities from different parts of the Philippines, from Luzon to Mindanao, and we had 2 conditions. We had 4 conditions. One was a static condition where they just read the code that was that they couldn't modify. So it was a PDF that they were reading. The other condition was dynamic, which is they they could actually edit the code using an integrated development environment. And then we had conditions where people were working individually, and we had another condition where people were working in pairs. So for combinations of conditions and all. We made use of the gaze point eye tracker, and this is how we set up the experiment. So the person working individually was seated here in the middle, and the two that were working as pairs, one sat here on the left and another one sat here on the right. And the reason why we kept them apart was because we wanted them to talk to each other, but we wanted to be able to record what they were saying. So they had to talk to each other using a chat. If we seated them side by side, then they might talk to each other verbally and we wouldn't be able to capture whatever it was they were saying. So we seated them apart deliberately so that they would be forced to use the chat to talk to each other. Okay. Now, what are some of the things that we found out? So this was the work of Christine Tablatin, who is finishing up her PhD. She used an approach called scan path trend analysis with a tolerance, and I'm not going to discuss the algorithm in depth because there's simply no time for that. But let me just jump straight into the findings. She tried to see what the patterns of eye tracking behaviors were for high-performing students and low-performing students. One of the patterns that she found, so the hypothesis was that high-performing students had a different way of scanning code than low-performing students. So the hypothesis was that there was a correct or a better way to read code, that reading code, that you could employ particular reading patterns to better understand code. And what did you find? Okay, so for both high and low performers, both high and low performers did the scan pattern, which was essentially that they did like a sweep of the code to identify major blocks. So both high and low performers did this. High performers did something called jump control, and jump control is that you basically trace the logic of the program. So in this case, you have a for loop here. The scan pattern essentially traces how the loop works. So you can see in the mind of the high-performing student, they're actually trying to perform the logic of the code. And so that's a pattern that we call jump control. Another pattern exhibited by high performers is something called word or pattern matching. They look for if it's a word matching situation, they look for, let's say, the same how a particular variable is used across the code. If it's a pattern matching situation, then they look for similar structures. Like in this case, you have several nested loops. You have a couple nested loops here and a couple nested loops here. So there's a tendency for the eye gaze to look at those very similar blocks of code and maybe trace through them. Now, what about the low performers? Low performers do this, what's called a linear vertical pattern, which is that they kind of just, there's this trace down, they go through, I don't know, three to five lines just sequentially without really looking at logic so much. And so there's this tendency to sequentially read. And take note that this first part of the program is not even the difficult part of the program. The difficult part of the program would be down here in the for loop, but instead there was some concentration on the top part of the program. There's also this tendency to do like a flicking pattern where they look at, let's say, a declaration of a variable, how the variable was used, back to the declaration, and so on. So it's almost like they're trying to make a connection between what this variable is and how it's used and what is it again, and how is it used again. And so there's a certain amount of parang having to remind yourself of what this variable was and what it was, what's being done to it. And then low performers tend to do this other pattern, which is called thrashing. And this is essentially a case where they go to different parts of the code without really any, without following logic or structure. So, or sequence. They just keep going from one part of the code to the other. It's an expression of being lost to some extent because they're not really sure what it is they're looking at. So what Christine did after finding these different patterns is that she tried to teach the better strategies to her students. And so part of, well, because this is something we don't explicitly teach in this way. We teach people logic, but at the same time we don't, but we don't actually tell them this is how you should try reading the code. But in what she did for her classes, was she actually tried to teach them how to read code better. And the initial results, at least from that effort, was that the low performers actually did improve in their reading of code. Okay. Now, what about programmer pairs? What did we find out about programmer pairs? This was the work of Maureen Villamor, who is with the University of Southeastern Philippines. By the way, Christine Tablatin is with Pangasinan State University. So Maui Villamor is currently, if I'm not mistaken, Dean of the Graduate School of USEP. And what she did was she analyzed how pairs of programmers work together. She was very interested in how they collaborated, and she tried to differentiate the behaviors of successful and unsuccessful pairs. Collaboration in the context of programming in general, is defined as working together to achieve a common goal. And in the context of programming, it refers to how well you were able to debug the code for our purposes. She defined a successful pair as those pairs who had an average debugging score for the 12 programs that was greater than or equal to the mean score. So if you were greater than or equal to the mean, then you were a successful pair. If you were lower than the mean, you were an unsuccessful pair. She made use of a method called cross-recurrence plot analysis. And again, unfortunately, because of lack of time, I'm not going to get into this in detail. But essentially, you end up taking the eye gazes of your two collaborators and creating a plot similar to this. And when you look at the plot like this, it's very much like reading tea leaves. You look at this and think, okay, what exactly am I looking at? From a plot like this, you derive certain metrics. And for those of you who are very interested, I'm happy to discuss with you more. But just suffice it to say for now that she took the raw data, she created the plot. From the plot, she derived all these different metrics. And what she found from these metrics were that successful pairs tend to share very similar and short scan paths, which imply that they are more strategic and more precise. So parang they know what it is that they're looking for. They're able to zero in on the parts of the code that are most relevant. They're able to trace the error relatively quickly. They don't need to read the entire program. They just have to focus on a specific number of elements for a fixed period of time. And they work relatively quickly. They find more errors. So it implies that they're able to understand the code and they're able to comprehend it much more quickly. For unsuccessful pairs, there's this phenomenon of staring but not seeing. So they tend to, their fixations tend to cluster, and they tend to repetitively look at the same locations but without actually seeing the error. So for example, this here is a plot of the gazes of one unsuccessful pair. So you have yellow and blue. So yellow is one partner and blue is the other partner. And if you turn this into a heat map, you'll see that, okay, a lot of the gaze concentration is here, here, and here. And the bug was actually here. So they saw it. They saw it. Both partners saw it. But look at where they marked. They marked here and they marked here. They didn't actually mark where the error was. So they stared at it. Both of them, both partners stared at where the bug was. And yet they didn't see it. Okay. So that was an example. Okay. Other characteristics of unsuccessful pairs are this thing called unfocused gaze. So they look at more elements within a given time window. They look at a lot of stuff, but with no, specific focus area. And then they needed a lot more time to understand the program. So what we learned so far is that high-performing students, even when they're working in pairs, they do have different behavior for reading through code, and they have and I think what's most important is it is possible to teach these behaviors, which is what we were really getting at, because Christine and Maui and we all teach computer science students and IT students, and as everybody here knows, programming is the first order of business for any of these students. So if you, as teachers, it's important to us to be able to teach effectively and to find out what skills can be taught, maybe how to teach them best, and so on. So these studies have encouraged us in the way that that it is possible to teach comprehension, reading, tracing, debugging, and we can make an argument that there are better ways. It's not just here's the code, read it, figure out what's wrong with it, but rather this is how we recommend that you read through it so that you can understand it better, and so you can trace through it better, and you can be a better programmer overall. So it's so this is one of the things that I really wanted to share with you, that at the end of the day, after all this analysis, it might seem commonsensical, but now we have data to prove the point. Okay, I have written some the references for this talk. There are others, of course, but and I assume that these slides will be made available to you if you're interested. And I wanted to say thank you to those funders who supported us. So this includes the Ateneo de Manila, of course, the Commission on Higher Education, the OST, and Private Education Assistance Committee, without whom this research would not have been possible. So thank you so much. If you have questions, I'm happy to take questions now, or you can email me as well.
Okay. Thank you very much, Professor Didith. So there are many very good insights from your talk. And also thank you for giving this talk at this unholy hour. I understand it's quite early there in Netherlands where you're giving the talk. So I have a question. This is more general. What are the opportunities for applying AI in education? Well, as somebody who's an expert in this general area, where can we focus our efforts, our research efforts should we want to venture into this field of AI in education?
Right. I think one of the big challenges for us, and this is something that we continue to struggle with, is that okay, there are lots of applications available, many of them for free, that actually are built on top of AI, that help guide students through material like math or science, and they are, they are available. Um, in fact, if I may shamelessly plug, we have a YouTube channel, also a YouTube channel, where every week we release a short video about some free innovation that many of which make use of AI. So if you were a teacher and you wanted to actually make use of these applications, you can, because most of them, or everything that we cover, is freely available. The problem is twofold. One is that many schools and many students don't actually have access to the internet or to devices. So even if teachers want to be able to use these innovations in their classes, they might not have the underlying infrastructure to do it. That's a big challenge, especially among our public schools. And what the irony of it is that these innovations have been shown to work and can really boost learning as well as improve the learning experience. However, ironically, the people who need them most, such as our students or students from other communities that are less resourced, these are the students who cannot access them for lack of underlying infrastructure. So that's one. Second challenge is that our teachers also need help and support with exactly how to use these innovations, because they can't just tell their students to, okay, go to this website, use this math application for 30 minutes and then come back to me. I mean, it really does have to, these innovations have to be folded into the lesson plan. There has to be contextualization. You have to embed the use of the software in a continuum. So there is some lesson that comes before it. Then there's the usual like motivation and whatever. Then you make use of the software, and then there's some kind of assessment and processing after. So if the teacher isn't coached and supported in creating those types of lesson plans, then it's a struggle, because it takes time and it takes some confidence and takes practice also. So those are the two things that kind of get in the way.
Are there insights from your eye tracking studies for programmers that are applicable or generalizable to learning how to read, for example, or for learning mathematics? I understand that this is a big problem for grade school teachers who are teaching their students how to even read or even
Right.
just understand basic mathematics.
Yes, I agree. There are actually, we have somebody who did his master's and is now doing his PhD on reading word problems in math. And as you said, this phenomenon of staring without seeing, it happens a lot when students read a word problem. They don't pick up on keywords in the word problem. That's why their solutions end up being wrong, not because they don't know the math, but because they don't pick up on certain keywords like PROS has 5 more apples than did it. So parang they don't get the more. So so they're not able to solve the problem correctly. And then for reading, like reading in English, there are studies. We don't have students who are doing this, but in other countries, there are people who do studies using eye tracking for reading, and they find that they're able to see whether text is too hard or too easy. If text is too hard, then reading is I think is extremely fast because the students simply skip over the words that they don't know. Or if it's too easy, then reading is very fast as well. But there seems to be this sweet spot where the difficulty level of the reading material matches the reading ability of the student, and so the pace of reading is quite reasonable. You can tell that students are actually reading properly, and if they stop on a word, that might be a clue that they don't understand what that word is.
Maybe we can hear some questions from the audience.
Ross?
Yes.
Yes.
Yes, I'd like to thank Didit personally, but I'd also like to give her a chance to talk about her ALLS program at the Ateneo. This is very important, I think. Didit?
Yes, ma'am.
Yes, your ALLS. So I've been revisiting your site. Okay.
Oh,
Yeah.
thank you. Well, the ALLS, or the Ateneo Lab for the Learning Sciences, is a research lab that I established in 2010, I believe. So it's been around for about 10 years. And we do two things. One is we develop educational software. And the other thing is that we use analytics to understand how people learn. We have actually several learning applications that are free, and I will go to the website just so you can share it. I will share my screen again. Here, if you go to the ALS website, which Dr. Giselle was kind enough to share with you in the chat, you'll see that there are links to the materials that we have developed, and the most recent. So all of these are available for free. Most of them are available for Android and for Apple, for iOS. The one that I will plug at this point is this this mobile app called For People and Planet, an SDG Adventure. This was just recently completed. So it's available for Android and for Windows. And essentially it teaches about the Sustainable Development Goals. We worked with the Ateneo Institute for Sustainability to make this. You have 5 stories: What's for Lunch, Flood Fighters, Walk in the Park, Work, and Learning is for Everyone. And essentially, you follow the day in the life of a young preteen student, and you go through this process of let's say getting ingredients for lunch and making lunch and cleaning up, and in the process you see how these activities tie into the Sustainable Development Goals. So that way we try to situate the Sustainable Development Goals in day-to-day life and in day-to-day life choices, so that the SDGs aren't something that's very sort of abstract and things that big institutions do, but not things that I as an individual do. So we're trying to change that. We're trying to convey to the users and to the students that the SDGs are alive and well in our day-to-day choices. And again, this is available for free. So anybody who wants to download it can download it.
Thanks.
And if
Didi.
there are any teachers, in the group today who are interested, please feel free to email me. We're happy to talk to you about it. We actually have a teacher's manual, which is also available for free, and you can you're more than welcome to use this in your classes.
Thanks, Didi. Ross, I think
Thank you very
we're
much.
concerned with values, right? Ethics and values. So SDGs are good to highlight. And Ross, may I at this point call John Kokoy, Ryan Dijon of Bataan Peninsula State University, who's concerned about waste upcycling. So right along.
Yeah.
Kokoy, would you like to speak? Kokoy? Well, I'm not sure, Didith, because Toby Direct is directly involved in our project with Kokoy in Bataan. Okay, and we're doing the MOU signing next week. It's postponed from tomorrow to next week. So I thought Kokoy might want to say something.
Okay.
He's at a meeting at Issured now. So Kokoy cannot speak now. He's at a meeting with DOST Issured about his projects. Thanks, Didith. Thanks, Ross.
Thank
Thank
you,
you very
ma'am.
much, Didith. Prof. Gisela, you may want to give some final words to our audience.
Oh yeah, so Ross, I just emailed you too saying that we should keep this going. Particularly Rec 10 should really champion many more high school and undergraduate students to pursue STEM, and in particular comp sci, stat, physics, what you would call the hard sciences. And bottom line, as Seth said, you must learn to do the Excel file well, even before thinking about AI, things like this.
Basics.
And so, we have to go on this campaign, and let's get the Rec 10 webinars going on a regular basis. Next one, you said, we're planning has to do with ethics and values. We're both concerned with this, Ross. And I'm glad that Didith and Steph and Erica are right on spot with the values or ethics required in data management or data insight. So I'd like to invite you, Pros, and Erica, Steph, and Didith, maybe to consider being guests, say, at the Math Dali or STEM Dali program of knowledge channel, so that you can still have another venue to share this important field of careers and the research, okay? Whether in academia or in government or the private sector, with our youth. And that's the only way we can sustain this. Maybe a final word from Steph and Didith on this matter. I understand Erica is gone. And well, I'm always concerned, Ross, about the few numbers of our S&T experts in the country, which Steph recognized. Okay, the ecosystem is still weak. But what can AI, the field of AI, do to try to solve this problem on the ground? Okay, so I don't know. It's a major challenge in our country.
Okay. I guess we have to end this webinar. And thank you, Professor Gisela and staff, Didith and Erica, for joining us and giving us these very Very interesting, very engaging talks. And to the audience, we'd like to see you again sometime next month. Goodbye.